Hey, ready for another walk? Today, we're moving forward on our data journey with a closer look at predictive analytics. Building on what we've learned from descriptive and diagnostic analytics, predictive analytics is all about answering the question, what might happen next? At its core, predictive analytics uses historical data to forecast future outcomes. It's like using what we know from the past to make informed guesses about the future. While we're not trying to predict the future with absolute certainty, this type of analytics helps us get a pretty good idea of what could come next. Imagine you're working with sales data and you've already uncovered why certain trends occurred. Now, with predictive analytics, you can use that information to forecast what sales might look like next month, next quarter, or even next year. How does it do that? Predictive analytics uses techniques like statistical modeling, machine learning, and algorithms that sift through data patterns to make predictions. But we won't get into all that technical stuff here. We're keeping it light and easy. Instead, we'll focus on why predictive analytics is so valuable. By looking at potential outcomes, businesses and individuals can plan ahead, make smarter decisions, and get ahead of the curve. Whether it's anticipating customer needs, managing inventory, or even personalizing recommendations, predictive analytics opens the door to a future guided by data. So, as we walk today, let's think about how predictive analytics helps us move from why did this happen to what could happen next? Stay tuned, because after this, we'll dive even deeper into prescriptive analytics, where predictions turn into actionable strategies. In predictive analytics, the key focus is looking ahead, using data from the past to make predictions about the future. This process doesn't emphasize cleaning or summarizing data. Rather, it's about identifying patterns in historical data and using models to forecast future outcomes. One of the core steps is pattern recognition. And it's essential to note that this activity differs from what we do in descriptive analytics. In descriptive analytics, pattern recognition is more about quick and basic derivations, like spotting a clear trend or a notable change in the data. However, in predictive analytics, we go further, using models to uncover hidden insights that aren't immediately visible. Techniques like exponential smoothing, ETS, ARIMA, allow us to find deeper, more subtle patterns that help forecast what might happen next. Once patterns are recognized, we move on to building predictive models. This involves creating statistical or machine learning models that take the patterns we've identified and use them to make predictions. Methods like linear regression, logistic regression, or random forests are commonly used here, depending on the nature of the data and the prediction goals. Finally, testing and validation ensures the accuracy of our predictions. This step involves validating the model's performance, often using techniques like cross-validation or backtesting to confirm the reliability of the forecasts. By concentrating on pattern recognition, building models, and testing predictions, predictive analytics is all about using the past to inform the future, helping us to anticipate what might happen next and make better decisions. Now let's dive into the tools that make predictive analytics so powerful in forecasting future outcomes. These tools help us go beyond merely identifying past trends. They allow us to make informed predictions about what's coming next. Time series analysis is crucial when working with data that changes over time. Techniques like exponential smoothing, ETS, and autoregressive integrated moving average, ARIMA, are commonly used to analyze time series data, helping us predict future values based on past observations. These models are particularly useful when identifying seasonality or long-term trends. Regression analysis plays a key role in predicting outcomes based on relationships between variables. In predictive analytics, techniques like linear regression and logistic regression help us estimate future trends by modeling the impact of independent variables on a target outcome. These models are often the starting point for forecasting numerical or categorical outcomes. Machine learning models take prediction to the next level by uncovering complex patterns that traditional methods might miss. Algorithms such as random forests, gradient boosting machines, GBM, and support vector machines, SVM, can be used for tasks like classification and regression. These models are particularly effective when dealing with large datasets and more intricate relationships between variables. Neural networks are powerful tools used in predictive modeling, especially when working with unstructured data like images, text, or time series data. Models like convolutional neural networks, CNNs, and recurrent neural networks, RNNs, are designed to detect patterns in highly complex datasets, allowing us to predict outcomes that might be too subtle for simpler models to detect. Predictive analytics in time series. Forecasting often involves tools like Prophet, designed to handle seasonality and trends in a scalable way. These tools are tailored for business use cases where forecasting is essential, such as predicting sales, demand, or customer behavior. Ensemble methods combine multiple models to improve prediction accuracy. Techniques like bagging, e.g. random forests, and boosting, e.g. XGBoost, light GBM, help create more reliable models by leveraging the strengths of various algorithms. This makes them highly effective in delivering robust predictions. Lastly, model validation is key to ensuring our predictions hold up in practice. Techniques like cross-validation and backtesting help us measure a model's performance by testing it on new or unseen data. This step is crucial in predictive analytics, as it ensures our predictions are accurate and reliable. By leveraging these tools, predictive analytics enables us to not only identify patterns, but also make informed forecasts about future events. Each tool plays a distinct role in helping us move from understanding the past to anticipating what's coming next. Following our previous case where Alex used descriptive analytics to organize and summarize customer purchasing data, and then applied diagnostic analytics to uncover the root causes behind certain trends, Alex is now ready to take the next step. With a solid understanding of why past events occurred, Alex turns to predictive analytics to forecast future trends based on these insights. First, Alex starts by recognizing patterns in the data uncovered during diagnostic analytics. With the root causes of purchasing behavior identified, Alex now wants to predict future sales trends. For example, Alex might ask GPT, "Can you help forecast the impact of seasonal trends on future sales?" GPT analyzes the data using exponential smoothing, ETS, and confirms that sales tend to spike around the holidays. This insight allows Alex to anticipate when the next sales surge is likely to occur. Next, Alex builds a predictive model using the factors identified in the diagnostic phase. Alex might prompt GPT, "Can you create a predictive model to estimate the effect of upcoming promotions on sales volume?" GPT uses linear regression to model the impact, providing results such as, based on historical data, the promotion is expected to increase sales by 15% next month. This prediction helps Alex make informed decisions about inventory and marketing. After building the model, Alex tests its accuracy to ensure the forecast is reliable. Alex asks GPT, "Can you run a cross-validation to verify the sales prediction model?" GPT performs the cross-validation, reporting, "The model's accuracy is 85%, which suggests it performs well on new data." This gives Alex confidence in the predictions, ensuring the company can make future plans based on trustworthy insights. Alex then extends the prediction to cover a longer time horizon. Using ARIMA, Alex asks GPT, "Can you forecast sales for the next 12 months?" GPT runs the time series model and predicts sales trends across the year, showing periods of growth and potential dips. This forecast allows Alex to plan resources and marketing efforts well in advance. Finally, Alex leverages machine learning for a more comprehensive prediction. With multiple factors in play, such as promotions, pricing strategies, and customer demographics, Alex asks GPT, "Can you use a random forest model to predict sales based on these variables?" GPT builds the model and offers insights like, "The random forest model predicts a 20% increase in sales next quarter, driven primarily by targeted promotions and adjusted pricing." This comprehensive forecast enables Alex to refine strategies even further. By using predictive analytics tools, Alex can now move beyond understanding why things happened to predicting what will happen next. With these forecasts, the company is better equipped to anticipate changes, make proactive decisions, and optimize future business strategies. Having explored predictive analytics, we've ventured into the powerful realm of forecasting future trends based on the patterns and insights uncovered from our historical data. By recognizing key patterns, building predictive models, and validating their accuracy, we gain the ability to anticipate what's likely to happen next. This phase builds on the deeper understanding provided by diagnostic analytics, moving us from identifying the why behind past outcomes to projecting what could happen in the future. With these predictions, we're better equipped to make proactive, data-driven decisions that guide strategic actions. Understanding the future is a critical step in turning insights into opportunities. By forecasting what's ahead, we can prepare for potential challenges, capitalize on upcoming trends, and make more informed decisions that drive success. To support your exploration of predictive analytics, I've included a list of sample prompts in the description below. These prompts are designed to help you apply predictive analytics techniques and develop forecasts for your data. Thank you for joining today's discussion, and I look forward to continuing our journey in the next episode. We'll dive into prescriptive analytics, the phase where we turn our predictions into actionable strategies that drive results. Until next time.